Now the question is posed, what's the work per unit charge? Well, here's the work done by the field, this expression, to get the work per charge brought, per unit of charge brought to the proximity of Q. Well, little q is the charge that's being brought in. So we're going to divide that work by little q to get the work per unit charge moved to within this proximity of the charge big Q. Okay, so we divide that, and it's very clear that we divide that, and if we divide this by little q, we get kq over r, k times big Q over r, with the negative sign, so negative k times big Q over r. Now we ask, what's the change in the potential energy? Now it's obvious, first of all, so whatever we get should be consistent with this intuition. It's obvious that as we move the charge closer and closer, we've got to do positive work. Now, just as we have to do positive work in this situation, if I lift an object against gravity, I've got to do positive work. If I lift an object against gravity, I'm exerting a force in this direction. Gravity is exerting a force in this direction. Gravity is exerting a force in this direction while I'm moving in this direction, so gravity does negative work, but I'm increasing the potential energy. So the potential energy increase is equal and opposite to the work done by gravity. Gravity is another conservative force. This is a conservative force. We haven't seen that yet. As I said, we're going to prove that. But remember that the change in potential energy I've defined throughout this course is equal and opposite to the work done by a conservative force or conservative field. Okay, so here's the work done by the conservative field. The change in potential energy is equal and opposite to that, which is k times big Q little q over r squared. The change in the potential energy per unit of charge moved here is what we call the change in electrostatic potential, or the change in what we call voltage. Okay, the change in electrostatic potential is change in potential energy over Q, and dividing out the little q, we get k times big Q over r. So there's our change in potential energy per unit of charge, our change in voltage.